Namaskar my dear friends. Let us talk about XR2206 function generator. It has a capability of generating a square wave, sine wave and triangular wave as well. So this is the complete implementation that we will be talking about and what are the different things that has been taken care here, right? So before that we have already seen this is the particular board that is available in the market directly from, let's say you can buy it from robu.in, okay, or there are a lot of other vendors also, but I have bought it from robo.in, and this is very useful board for your students projects or like any of the function generator that you want to generate from, let's say, up to 25 megahertz or something like that. Let me just see the range. So you can see it has a capability of 1 hertz to 1 megahertz range, and it also supports amplitude waveforms from 0 to 3 volt DC, and it has a capability of sine, square and triangle. So this we have already discussed. Alright, so our main aim would be to understand the IC details and design and what are the things that we should take care of. So as you can see, this is the IC that is there from Max Linear. Anyway, this particular IC is no longer produced, okay, so I mean you don't think of utilizing this thing in your upcoming projects. However, this is still very versatile and very like popular for students projects because it has a capability of giving you very nice output waveforms as per your requirements. So as you can see, this is the pin configuration for this particular IC. So this is 16 pin IC which is having AMSI pin and all these pins are there that we'll already talked about. So while designing the circuit, we will see the pin descriptions and their functionalities. Okay. So as you can see, if we directly jump into the design implementation, so what I have done is I have taken a connector which will be utilized for your power supply input. Okay. And this power supply input you can connect a DC-DC converter or DC power supply directly at these two pins and it will give you, so connect it to around 12 volt voltage ratings. Okay, and I have put here Zener diode also so that it can regulate the output voltage to 12 volt. Okay, and we have a fuse for safety protection as well. The other thing that is there here is I have put a jack connector also, so there are a lot of power adapters that is coming, let us say 12 volt power adapter, so you can utilize 12 volt power adapter also to power this particular IC. Okay, so either one of them can be connected. So this is one that I wanted to tell you. Next, coming back to the output, so output we have sine wave and triangular wave output at this line which is pin number 2, and then we have a square wave lines which is at pin number 11. Okay, and this is the connector that will be utilized to see the output so that you can connect it to your oscilloscopes or any output like a viewer that you can see. At the same time, same connector can be utilized to give a FSKI signal, that is your frequency shift keying signal. I have removed amplitude modulated shift keying, okay, so that we have removed, and this is the ground lines. Now coming back to the complete circuit design, so as you can see we have timing capacitor input. So timing capacitor input is there here, so between pin number 5 and 6 you can connect timing capacitor values. Similar to that we have timing resistor values. If you want you can remove one of them, keep it floating, okay, and another you can connect it here. So 120 kilo ohm I have taken. However, the range is from 1 kilo ohm to 2000 kilo ohm. Okay, 2000 kilo ohm. Now why we put this RC is actually going to give you your output frequency rating. So output frequency will be actually measured with 1 by 2 pi RC. Okay, so that's the formula that will be utilized to give you the output frequency at this particular points. Okay, now coming back to the other points, like we have bias point. So bias pin will be grounded with 1 microfarad capacitor. So this is nothing but your internal regulator voltage. Okay, then we have MO pin. So MO pin is nothing but your multiplier output. So multiplier output will be actually put through one of the like pot, that is your variable resistor. Okay, so this variable resistor is used 25 kilo ohm, and you can rotate it and change the value of this particular multiplier so that you can change the output. Okay, Coming back to the supply voltage, so I have supplied voltage with 12 volt rating here at pin number 4 with 10 microfarad like a capacitor and 0.1 microfarad filter capacitor. So this is for transient suppressor or kind of working as a bulk capacitor. Okay, we have SYMA pin. So this is nothing but your variable resistor again. So this is actually work as wave symmetry adjustments. Okay, so wave symmetry adjustment, you can adjust this particular resistor, or otherwise you can keep it not connected also, so that nothing will happen. Okay, but this is suggested. Coming back to this wave A and wave B, that is nothing but waveform adjust inputs. So if you want to have, what are the different things that is there is, let's say if you want to have a square wave output only, then you don't need to connect this. So you just disconnect this particular jumper. So this I have put jumper sort. Okay, and then at the same time, if you want sinusoidal or something like that, let me just see the waveform here. So as you can see, there is just one closed for sine wave and open for a square wave. Okay, so that's the reason I have put here for sine wave you have to connect this particular jumper so that it will give you sine wave, and this is the variable resistor that will be utilized to adjust the waveform. So this is completely. Now coming back to this square wave output. So square wave output has open drain output. So in open drain output you must pull it up. So that's the reason I have pulled it up with 10 kilo ohm to the VCC. So this is the complete circuit that was there, and as you can see, this is very simple board, and that is available in the market as well directly with less than around some 1000 rupees or maybe some 500 rupees. So you can directly buy it and play around with this particular board. If you talk about some of the circuits that is given in the data sheet itself, so there are a lot of basic test circuit that is given. So with this circuit you can see there is one switch here, or maybe I have put just jumper sort. So for that you can utilize is open for triangular and closed for sine wave. Okay, coming back to other parts, like we have triangular or sine wave output at pin number 2, then square wave output at this, and this must be pulled up because it is open drain output. We have timing resistors, then we have timing capacitor, then we have ground pin, we have FSK input. Okay, so all these things are there. This is pin number 1 is nothing but your amplitude modulated shift keying, so that is grounded. Okay, and this is my power supply. Another test circuits are there which is given as like sine wave generator. So in sine wave generator you can see a lot of the pins have been left open. So pin number 16 and 15, which is nothing but your wave symmetry adjustment, that can be left open. So it is very simple circuit. For timing resistor you can put one variable resistor as well, so that you can vary the values and you can vary the output frequency. Okay, so the thing what I have designed here, you can utilize here variable resistor to vary the output frequency. Okay, coming back to the other parts, one more circuit was given in the data sheet. So this is this circuit. So this can give you like a circuit for pulse and ramp generation. So pulse output, if you want like a square wave output, so that can be directly taken, and pin number 9 you can see we have frequency shift keying pin, so that has been taken directly here, and this is actually taken as a feedback to give you a pulse waveform. Okay, so that's all. With this you can see we have a duty cycle setting, which is going to be R1 by R1 plus R2 is nothing but this is timing resistor, which will set the duty cycle of the output. At the same time we have frequency setting, which is going to be 2 times 1 by R1 plus R2 into 1 by C. So that is your timing capacitor. Alright guys, so hope you have a good understanding how to start designing the circuit, how we can put our input like connector or input jack connector for power supplies, and how we can design the symbol with particular understanding. And the change that you can do is you can connect here one variable resistor, so that you can vary the output frequency very easily. So that's the only change if you want you can do it, and this is complete circuit that you can utilize for your projects or different waveform generator in very basic format. So if you do have any questions regarding your XR2206 function generator projects, or like how to start with the circuit designs, you please put down your questions in the comment box and we shall be able to give you answers. Thank you.